On your first page is a recap of all the exponent rules which you will need to master for this unit. This is a revision from Year 11. Please pause the video now and try to fill it in, and in a few seconds I'll show you the answers. Here are the answers, and you can pause the video again to check what you've done. Alright, and so if you have a look at the next page, you see a graph of an exponential function, 10 to the power of x. Okay, we're looking at what might be the inverse of such a function. Remember, it's a reflection of the line y equals x. And we're obtaining this blue curve here with some very interesting properties. Over here, it grows incredibly fast, and then once it becomes positive, the growth slows down and slows down, quite the opposite of the exponential function, in fact. So, this thing here, we're asking with y equals log base 10 of x, we're asking 10 to the power of y will give x. That's what we're stating. 10 to the power of something will give x. So when we write log base a of b, we'll just say log a b, we're saying a to the power of what will give b. That's what this means. And so if you look a bit further down, when we're looking at log 2 32, we're asking 2 to the power of what will give 32. And of course 2 to the power of 5 is 32. That would be the answer. So log 2, log base 2 of 32 is equal to 5. Alright, so if we look at this page, 7 to the power of what we can ask is equal to 49. That's what log base 7 of 49 equal to 2 means. And of course, 7 to the power of 2 is 49. Log base 8, 4 equals to 2/3 means the same as 8 raised to the power of what will give 4. And of course, 8 raised to the power of 2/3 equals to 4. Stop the video here for a moment to actually work that out based on the indices rules from the first page. Note that here, see that 8 is the base, just like it is the base here in this expression with the base and the power. If we look at this one, this is the same as asking 10 to the power of what will give 1/10, because log without a number here is the same as log base 10. That's just like a shortcut. If it's log base 10, then we don't write it there. We just write log. And so you would answer the question by writing 10 to the power of minus 1 equals 1 over 10. Hence, the answer to this expression is -1. The other way around now. 3 squared equals to 9. You would write 2 equals log 3, 9. 2 is the power that you need to raise 3 with in order to obtain 9. Here, we get b equals log ac. Same way. And here, this is a -3/2 here. -3/2 equals to log 4 of 1/8. Alright, so now in this exercise where we actually need to finish the sentences here, well, we ask ourselves 5 to the power of what is 625? And of course 5 to the power of 4 is 625. 4 to the power of what equals to 28? Well, 4 to the power of 7 halves. And I know this because I can write 2 to the power of 2 instead of 4, and then to the power of what is 28. And now I know that 2 to the power of 2 times 7 halves is 2 to the power of 7, using the indices rules from page 1. Check that out. And 128 is, of course, 2 to the power of 7. For this one here, well, I can change this first 7 to 7 to the power of 1, and then square root of 7 is 7 to the power of a half. And using the indices rules again, I have 7 to the power of 3 halves. So if I ask 7 to the power of what is 7 to the power of 3 halves, well, I'm getting 3 halves here. Again, pause the video to work this out for yourselves. Right, this time I have a little equation to solve, but it's using the same principle. 2 is my base, 2 to the power of 8 is equal to x. Well, then x must be equal to 256. That's what's 2 to the power of 8. Here, log base 10, there's no log here, I'll write it just for the exercise. Log 10 of x equals to 6. Well, that means 10 to the power of 6 must be equal to x, and therefore x is 1 million. And now for this one here. This means x to the power of 4 over 5 equals to 81. Okay, now let's first of all rewrite the 81 as 3 to the power of 4. And now let's work on the left hand side. This can be rewritten as x to the power of 1/5 to the power of 4 using the indices rules. And that's equal to 3 to the power of 4. So by comparing left and right hand, it's both to the power of 4, so I can write x to the power of 1/5 must be equal to 3. And now x to the power of 1/5 is the same as the 5th root of x. Again, look on page 1. And finally, if I have the 5th root, well, what I can do is I can do to the power of 5 to undo this to get to x. Okay, that's the inverse operation, and I get 3 to the power of 5 on the right hand side, which is 243. So x equals to 243. And on to the next page. Log of 2, remember that's log base 10 of 2, so that's asking 10 to the power of what will give 2. That's obviously going to be some fractional number. Okay, so if you take your calculators, the log key is the one is always log base 10, right? So actually you get approximately 0.778 if you do that. And if you do log of 6, log of 2 times 3, you also get 0.778 approximately. And if you repeat that here for this exercise, and then confirm for yourselves that we seem to be getting this rule that if we have two numbers that are multiplied and the log of that, then it's the same as adding the logs of the two numbers separately. Do this here, stop the video and do this to confirm that, and then do the rest of the page here, including the things here and writing up the laws. Well, I'll do this one for you. This will be log a m minus log a n, and you can confirm that for yourselves. And eventually for the bottom one, just to make sure that you've got that complete, this is n log base a of m. But if you do these examples on your calculator, you should get to that yourself. And so finally, we should have no problem doing these exercises using the rules that we just did on the previous page. Log 4 plus log 3 must be the same as log 4 times 3, which is log 12. This must be the same as log 5 times log 6, 5 times 6 divided by 2. So that would be log of 5 times 6 divided by 2, which is the same as log 15. Again, take your calculators to check that. This here, okay, that reminds you of the third rule on the previous page. So we're going to say this must be log 5 squared times 2 to the power of 3. These two are added, so we're using the multiplication rule. And then there's plus log 1, but log 1, 10 to the power of 0 is 1, so that's actually 0 and the whole thing falls off. That becomes 0. Again, stop the video if you need to think about that. And then 5 squared times 2 to the power of 3 is 200. On this one, 3 becomes a power, so we have log of x cubed minus log base 10 of y, and then the half becomes a power 2, log z to the power of a half. And so if I combine all three, I can write it as one big fraction, 1 logarithm x cubed multiplied by z to the power of a half divided by y. Okay, that's how far we're going to go today.